Welcome to another amazing time with Mr. Moses. In our last tutorial, we were able to talk about how we can be able to carry out the experiment, the compound pendulum. So, for the last practical, we were able to follow the simple procedures to be able to work on the compound pendulum experiment. But we were unable to finish the lesson, so today what we'll be doing is that all the data gotten from our compound pendulum, we are going to be using those data to determine the acceleration due to gravity g and the radius of gyration k. So this is an example of the table of value if you have done the practical correctly. This is an example of your table of value. So, in our analysis, the first thing we do is number one, you plot a graph of ht square against h squared. Number two, you measure the slope of the graph. Number three, measure the intercept on a square axis. Now, if you have been able to plot a graph of ht square against h squared and you have been able to measure the slope to get your slope to be equals to m, remember our slope is the change in the ht square axis all over the change in the h square axis. Now, for you to be able to get your acceleration due to gravity g and the radius of gyration k, we have a simple formula for the simple harmonic motion depicting the period of oscillation for a simple pendulum. So we have that t, the period of oscillation for a compound pendulum, is equal to 2 pi square root of a squared plus k squared all over g multiplied by h, where the value h there is just the distance between your point of rotation and the center of gravity. So using this equation, the next thing we do is that we square all through. We square everything so that this becomes t squared equals to 2 pi square root of a squared plus k squared all over gh all squared. So if you have done that, this will give us t squared is equals to 4 pi squared. The powers are evenly distributed. Then we have a squared plus k squared all over gh. Because this square we cancel out the square root. Okay, so if you have been able to do that, the next thing we do is that since we are plotting a graph of ht squared against h squared, what we are going to do is that we are going to make this equation linear such that ht squared is going to be on the left hand side of the equation. How do we do such a thing? Or what we do is that we multiply 2 by h, so that when we multiply 2 by h, this gives us ht squared plus ht squared equal to 4 pi squared. Then if we multiply 2 by h here, the h will cancel out this h here, so that we are supposed to have h into h squared plus k squared all over GH. So this we cancel out this. So we'll be left with HT squared equal to 4 pi squared to bracket A squared plus K squared all over G. So from here, what do we do next? So from there, we have that we are going to make this whole thing linear such that we have HT squared is equal to 4 pi squared H squared all over G plus 4 pi squared K squared all over what? All over G. Now looking at this equation, it is synonymous to what we have. Y is equal to what? Mx plus C. So if we say we are plotting a graph of y against x, m here becomes our what? Our slope. So if we are plotting a graph of ht squared against h squared, what will become our slope? Our slope m, which is going to become, which is equal to, remember our slope is normally equal to change in ht squared from your graph all over ht squared. So this is still equal to, from the slope of the graph, is still equal to 4 pi squared all over G. So if you get your slope from the graph, you can be able to equate your slope to 4 pi squared all over G. The next thing we can see here is that our intercept C is equal to this here. So that C, the intercept on the a square axis, will be equal to 4 pi squared K squared all over G. So if you have been able to, from this m is equal to 4 pi squared all over G, we can be able to say that our G is equal to 4 pi squared all over G, all over m. Now substituting G into this formula here, we can be able to derive the value for our K, where K squared is equal to CG all over 4 pi squared, and our K is equal to the square root of what? CG all over 4 pi squared, which is still equals to square root of CG all over 2 pi. So our radius of gyration K is equals to what? Square root of CG over what? 2 pi. Hence, from the formula, we have that our slope M is equal to 4 pi square over what? G, and G, the acceleration due to gravity, is equal to 4 pi squared over M. And our radius of gyration K is equal to square root of CG over 2 pi. So from your graphical analysis, you can be able to find the acceleration due to gravity by obtaining the slope and using these equations that I've just shown you. So if you have been able to follow this procedure and impute your values, you'll be able to derive your value for your G, which is the acceleration due to gravity, and K, your radius of gyration. I believe you have been able to understand how we can be able to determine the acceleration due to gravity G and the radius of gyration K from a compound pendulum experiment. Ensure you like this video, ensure you comment if you're having any issue, and also ensure you subscribe so that we can have more and more practical sessions and you can see more of my upload when they are uploaded. So thank you. See you next time. I remain Mr. Moses, teaching you guys on practicals. So bye bye for now. See you in our next practical session.